In this video lesson, we're going to be looking at content in Chapter 3, Section 3. We have several objectives. The first objective is that we want to divide polynomials. We're going to use long division to divide polynomials. Just be aware that division can be represented in different formats. I have this fourth degree function here, and this division symbol implies that I want to take this fourth degree polynomial function and divide it with that division symbol by a second degree polynomial function, or also known as a quadratic. If I don't use the division symbol, I can use a fraction bar. So notice this fourth degree function and this second degree function are the same functions I have here. If we don't use the division symbol or the fraction bar, then we can certainly go to setting up the division problem by using this division symbol right here. The steps used to divide polynomials are actually just the same as the steps that we used when we learned how to divide whole numbers. These are the 4 steps. We'll have practice with that in a minute. I think before we jump into doing division with polynomials, let's review division with whole numbers. It'll help us understand the process that we're going to go through in a minute. So I'm going to actually do 2 examples of dividing by whole numbers. You can just watch if you want, or you can write the problems down if you'd like to. Consider this division problem. If I want to do division the long way, without using a calculator, I would take 7, also called the divisor, and I'd put it outside this symbol right here, this division symbol, and then I'm going to put the numerator, called the dividend, underneath this, this symbol right here. So just some terms right here too. So a divisor is what we divide by, and the dividend is what we're dividing into. All right, so when we first learned how to do long division with whole numbers, we looked at 7 going into 4. It does not, but 7 does divide into 48. It'll go in 6 times. 7 would be too many because we get 49. And then what we did is we back multiplied. We took 6 and multiplied it by 7. We got 42, and then we subtracted. So now looking down in a column format, we subtracted, we got 6, we brought down the next digit, and we started the process all over again, called an iteration. Does 7 go into 63? Yep, it goes in 9 times. Back multiply, that gives us 63. We subtract, we get a 0. Then I bring down the 2. Well, 7 doesn't go into 2, so I put a 0. Then we bring down the next digit. 7 goes into 26 3 times. 3 times 7 is 21. Again, we subtract, and then we get 5. Now, I could add a decimal here, and then I could bring the decimal up here, and I could fill in a bunch of zeros if I wanted to continue this process and get my answer as a decimal. But for what we're doing today, we're not going to go that far. So I cannot divide 7 into 5, so we usually put this little r right here to represent the remainder. All right, a couple more terms. Okay, so the quotient is this part of the answer right here, 6,903, and then the remainder we're going to just call 5. Okay, let's do another problem. There's another objective here I want to kind of mention that'll help us with our later work that we're about to do. Let's take 4,134, this dividend, and divide it by the divisor 3. So the numerator goes underneath this symbol, whereas the denominator is the divisor, and it goes outside here. All right, 3 goes into 4 one time. Back multiply, that's 3. Let's subtract. We bring down this 1, and we bring down the next digit. 3 goes into 11 3 times. 3 times 3 is 9. We subtract. We get 2. We bring down the 3. 3 goes into 23 7 times. 7 times 3 is 21. We subtract. We get 2. We grab the next digit. 3 goes into 24 evenly. We get 8. 8 times 23, or excuse me, 8 times 3 is 24. We subtract, and we get a remainder of 0. All right, so we have a quotient of 1,378, and we have no remainder. We can put remainder 0 if we want to, but we wouldn't have to record that at all. We have a remainder of 0. Just some other things to think about is that when you do get a remainder of 0, we can then say that 3 is actually a factor of 4,134. 3 divides in evenly with no remainder, so that is called a factor. Back up here in this example, 7 does not go into this dividend evenly, so 7 is not a factor of 48,326. That's because we have a remainder. So when we do our division and we end up with an answer of 0, we can then further say that the dividend 3 is a factor of, the divisor of 3 is a factor of this dividend. And we'll be using that language when we look at dividing polynomials in a minute. Okay, so let's go back here to our notes. So the steps used to divide polynomials are the same. We first divide, and then we multiply back, we subtract, and we bring down the next term. All right, so right in here in this space is an example of polynomial long division, right here. They've taken the example that we had up here, okay, and then they put the divisor on the outside of this division symbol. They put the 4th degree function on the underneath of it. Notice that we had a 4th degree polynomial function and we went from a power of 4 down to a power of 2. So we have to put placeholders of 0 for any missing degreed terms. And then we want to keep the columns aligned by degree. Okay, so we can see that we have 4x to the 4th, but we want to fill in 0 x cubed terms. And then we return to the problem 5x squared minus 9x plus 18. So now we have a high exponent of 4, and then we have 3, 2, 1, and then we're down to the constant. Okay. All right, it's kind of hard to see how all this came together. So what I'm going to do is I'm going to take this example and I'm going to actually do this example step by step so that we can see how this, these other terms are kind of appearing here. Okay, so I'm going to go off to a different sheet of paper. You can write this down or not, or you can just watch me complete this example and just know that you have the example here. Certainly up to you. Okay, something probably worth noting is that we have to put placeholders only for the dividend, not for the divisors. So if I was missing one of the degree terms over here, I don't have to fill in any placeholders of zeros for the divisor, only the dividend. Okay, so what are they doing all over here? Well, like our examples of long division with whole numbers, the first thing I'd suggest is I would suggest taking the first term of the divisor and the first term of the dividend. So you're just kind of like covering everything else up. And then I always ask myself, what do I multiply x squared by to get up to 4x to the 4th? Another way to think about that is like what they did on their paper is they take 4x to the 4th and they divide it by x squared. My brain just thinks, what can I multiply x squared by this to achieve this term right here? Well, that's going to be 4x squared. So when you put 4x squared up top here, you don't have to align it right above the other term. I mean, you can, and it's suggested that you do, and maybe we will. But it's not wrong if you don't align it. What's wrong is underneath here is aligning the correct degree terms. All right, so let's back multiply. But now I've got to multiply 4x squared into all of these terms. So 4x squared times x squared gives 4x to the 4th. 4x squared times 2x, multiply 2 and 4, get 8. X times x squared is 8x cubed. So it's a good thing we filled in this 0 x cubed term here because we need 8x cubed to line up underneath it vertically. All right, and then we still have to multiply into the 4. So 4 times 4 is 16. That will become 16x squared, and I'll line it underneath this second degree term, plus 16x squared. All right, next we subtract. Well, we don't just subtract the first term, we actually go in and subtract all the terms. So for me, that just means if I subtract all the terms, it's just a matter of changing all the current signs to their opposites. So this was positive, I make it negative. This term was positive, I make it negative. This term is also positive, so I have to make it negative. Had any of these terms been negative, I would have changed those signs to positive. Now we look down and we see what can happen. These two terms should cancel when we collect them downward. If they don't, we made some kind of mistake. Now let's collect down here. This would be 0x cubed plus negative 8x cubed. That's negative 8x cubed. Let's collect these two terms that are alike, and that will be 5 minus 16 or minus 11x squared. You can bring down the rest of the terms all at once if you want to. We may or may not use them in this next iteration, but they'll be there. All right, so we start the process all over again. So we cover up all but the first term of the divisor and the new dividend. What do we multiply x squared by to get negative 8x cubed? If you want to think of it as negative 8x cubed divided by x squared, that's fine too. I know I need to multiply x squared by negative 8 and then another x. So negative 8x. So what do? I go back and multiply negative 8x into all three of these terms over here. So negative 8x times x squared gives negative 8x cubed. Notice they have the same sign because I haven't subtracted yet to change this sign. Once I do subtract and this becomes a positive term, when I add down, these will cancel to 0. So go back and do some more multiplication. Now I'm here at these two terms. This would be negative 16x squared. So put negative 16x squared underneath the other x squared term. And the last multiplication gives minus 32x. And that would line up underneath this other linear term. All right, let's go through and subtract, which means change this sign to positive. This is negative, so I change it to positive. This is also another negative, and I change it to positive. Now let's add down. Well, these two terms collect to 0. X squared and x squared are the like terms. We collect these coefficients. That's positive 5x squared. We collect these terms, and that's 23x. And I'll go ahead and bring down the 18. I can do division again because I have an x squared and an x squared here. So let's do the whole process again. What do I multiply x squared by to get 5x squared? Again, another way to think about that is, what is 5x squared divided by x squared? Well, that would just be 5. Back multiply. 5 times x squared is 5x squared. Notice right now if I were to add down, they would collect to 10x squared, but remember I've got to subtract here in a minute and they will cancel. 5 times 2x is 10x, and 5 times the 4 is 20. Let's subtract, which means subtract all the terms, make them all their opposite signs. Add down, those cancel. If they don't cancel these first two terms, that's kind of a red flag that we made a mistake. 23 minus 10 is 13x, and when I collect these two on the calculator, I get minus 2. Can I keep going? No, I can't, because now I have an x squared, and the highest degree I have here is a 1. So actually, I'm done. I've got a remainder, and my remainder is 13x minus 2. We could either use the little r, but oftentimes what we do is we say, okay, the quotient is this second degree polynomial, and we say we want to add the remainder. And when we add the remainder, we're going to add 13x minus 2, and we'll put it over the divisor. So if we're asked to indicate the quotient, sometimes we use function notation. We say the quotient is q of x, and it's equal to 4x squared minus 8x plus 5. And it's going to ask us to state the remainder in terms of x, because that's the letter we're using. And the remainder can be just reported as 13x minus 2. You could also put it over the divisor if you want to, but sometimes we just see it this way. Okay. All right, as a reminder back up here, We could have also said that our answer was 6,903 plus our remainder of 5 over our divisor in this problem of 7. And we can do the same thing when we deal with polynomials as well. All right, so let's go back to our notes and see if that's the same answer that was already printed here. Well, I did get 4x squared minus 8x plus 5, and I did get a remainder of 13x minus 2. And all of this work is exactly what I did on my problem. This is just reminding us that when we want to do an iteration, we could divide, okay, to get these values that are up here. And as a reminder, we could write this fraction or this division problem as the quotient plus the remainder over the divisor, like it's written here. Quotient plus remainder over divisor. So let's practice some more problems. So I'm going to actually skip over to a couple pages, and I've got some practice problems there. So as we go through each of these different objectives, I think there's 3 or 4 of them, I've got this sheet of practice problems for each objective. All right, let's divide using long division. State the quotient, q of x, and the remainder, r of x. Got it. All right, so in example 1, we have the division symbol here, so I'm going to leave a little space, and I'm going to put x minus 3. And then I'm going to, first of all, observe that this third degree polynomial has all exponents presented. I have 3, 2, 1, and a constant, so I don't have to fill in any placeholders. All right, long division says, cover up everything but the first term of the divisor and the dividend. What do we multiply x by to get x squared? Or, excuse me, what do we multiply x by to get x cubed? Well, that would be x squared. So I'll put it up here. Let's back multiply. X squared times x gives x cubed to line up underneath the other cube term. And x squared times minus 3 is minus 3x squared. Let's subtract. So this term is positive, I make it negative. This term is negative, I make it positive. Now our eyes should shift to column formats. These will cancel. If they don't, we made a mistake. Now let's collect these like terms. So that gives us 1x squared. Bring down the next term. You could bring down the last term if you want, just to have it there a little closer. Start the process over again. What do we multiply x by to get x squared? Well, that would just be an x. So a positive x goes here. Let's multiply x into both these terms. So I get x squared minus 3x. Let's take the opposite of all the terms. So opposite here, opposite here. These will cancel. I'll collect and get negative 2x, bring down the plus 6. What do we multiply x by to get negative 2x? Well, we'd multiply x by negative 2, so we record that up here. We distribute and get 2x plus 6. So 2x plus 6. All right, then we take the opposite. Oh, pardon me. So I'm so sorry. Oh, yes, that's negative 2. Sorry. Negative 2 times x would be negative 2x, and then negative 2 times negative 3 is plus 6. Now we take the opposite of all terms. That means we're subtracting. Make that positive, make that negative. These cancel, and as a matter of fact, we have a remainder of 0. So coming over here and recording, our quotient, q of x, is our answer up here. It's x squared plus x minus 2. We have no remainder. You could do r of x and you could put none, or you don't have to record anything. Or you could put 0. As a reminder, because I have a remainder of 0, I can then say that x minus 3 is actually a factor of that third degree polynomial. So when your remainder is 0, I can then say, hey, x minus 3 is a factor of that. And that comes up as something important in a little bit. All right, let's do another practice problem. I think I'm going to skip down here and do number 4 because there's a lot of placeholders I have to fill in. I think I'll do the work right over here. So x minus 3 is my divisor. I have an x to the fourth, but not a cubic, not a square, and not a linear term. So I've got to fill in 0x cubed, 0x squared, 0x, and then I can fill in a minus 81. All right, we may or may not need these placeholders, but they have to be there so we can kind of line everything up, and in case we do need them. All right, cover everything up. What do you multiply x by to get x to the fourth? You multiply that by x cubed. Back multiply, we get x to the fourth. Back multiply, we get minus 3x cubed. Take the opposite, negative, positive. Those will cancel, collect down, 3x cubed. I'm going to bring down the next term, so that's plus 0x squared. You certainly can bring down all the terms or wait till later. I might need them, I might not need them, I don't know. All right, start the process over again. What do you multiply x by to get 3x cubed? Well, you got to multiply x by 3 and an x squared. So I'll put 3x squared here and then multiply through 3x cubed. This becomes minus 9x squared. Take the opposite. Those will cancel. I've got 9x squared. I'll bring down the 0x in case I need it. I could also bring down the minus 81 if you wanted to too. All right, here we go at it again. What do we multiply x by to get 9x squared? Well, that'll be 9x. Multiply across here, that's 9x squared. This will be minus 27x. Remember to subtract, change this sign, collects to 0, collects to 27x. Now let's bring down the minus 81. I can keep going. What do I multiply x by to get 27x? Well, I'm going to multiply that by 27. Back multiply, 27x. This is actually going to be minus 81. Subtract here, add here. Those cancel, cancel also. So notice, just like in the first example, we have a quotient, q of x is this cubic or third degree polynomial, but we have no remainder. The remainder is 0. And then we could put r of x is equal to 0 or none. Okay, so what further information can we gain from this because we have a remainder of 0? Well, we can say that x minus 3 is actually a factor of x to the fourth minus 81. I don't think all my examples have a remainder of 0. It just so happens that the ones that I chose have a remainder of 0. Okay. Alrighty, and I'll do this last one, number 3 here, and I'll leave number 2. It is worked out on the key. If you want to attempt that one on your own and then come back and kind of check through on that one. All right, let's long divide here. Observing that my dividend has all exponents presented, I don't have to fill in any placeholders. All right, what do I multiply x by to get 3x squared? Well, that's 3x. Back multiply, 3x squared, back multiply, minus 9x. Subtract by changing all signs, collect, 7x plus 5. X divides into 7x. Okay, or I just multiply by 7. 7 times x matches this 7x, and then I have minus 21. Subtract, change that sign, collects to 0. My remainder is 26. So my quotient is 3x plus 7, but my remainder in terms of x is 26. I don't have an x here, but that's okay. So is x minus 3 a factor of that quadratic? No, because the remainder is not 0. Right, another way to write this, if you wanted to, is to come back up here to the quotient and say plus the remainder of 26 all over the divisor x minus 3. So it really depends upon how the question's being asked of you as to how you should present your answer. Okay. And here we were asked to state the quotient and state the remainder. So that's why I did it this way. All right, So that's polynomial long division. Okay, so now let's go back to our notes, the first page here. All right, so what about if we want to take a shortcut? Are there certain conditions of polynomials when we divide where we could do a shortcut? Yes, there is. We can use synthetic division, so also known as a shortcut, to divide polynomials, but only with certain division problems. And that's if the divisor is of this linear form, x minus c, meaning I can't divide by a quadratic. This has to be x to the first power plus or minus some other number here. So for example, back up here in this problem that we did, notice that the divisor is not a linear divisor, it's a quadratic divisor. So I could not use the shortcut method called synthetic division on this problem right here. So I can only use the shortcut method when I divide, the divisor is a linear factor. So if we go back just real quickly, kind of by inspection, and look at these 4 examples, I can use synthetic division because this divisor is a linear divisor. Okay? And we want a coefficient of 1. I could probably do it here, but it's a little more tricky, and we'll kind of stay away from this with the shortcut method. Number 3, the divisor is a linear divisor. I could use the shortcut method. And then also 4, I could use the shortcut method. Okay, so we'd get the same answer, but we're just taking a different route. Okay, so let's look at what synthetic division is. Now that we know when we can use it, okay, well, what is it? So what we do is, in this particular problem right here, we have to arrange the coefficients in an array in decreasing order with placeholders for missing degrees. For example, okay, look at our dividend. We're missing an x squared term, so we'd want to fill in a 0. But the cubic has a coefficient of 5, so a 5 here, 0 for the x squared term that's missing, 6 comes next, and the constant comes last. Okay, where did these numbers come from? Well, I'm about to show you. Okay, so where did this -2 come from? Well, actually, what we do is we look at the divisor and we think about, okay, what is the 0 of this divisor? So what zeroes out this divisor? Well, x equals -2, okay, would be the 0. So we take the -2 and we kind of place it over here to the left of all these numbers. Okay, these instructions right here tell us how we're going to actually find the answer to this division problem by using the shortcut method. Let me take you through an example of synthetic division like I did up here, because when you first look at all these numbers, you don't know where they came from. So I'm actually going to go back to my paper, and you can just watch because we'll have some more examples on our own. I'm actually going to take and do long division on this problem, and then I'm going to verify using the shortcut method that I can do the same. Okay. So that's what we'll do here. So I'm going to do one more long division problem. Okay, notice that I have to fill in a 0x squared. Okay, so kind of quickly going through the long division, I'd multiply by 5x squared, back multiply, subtract, subtract, bring down the next term. X divides into this first term -10x times, so -10x, back multiply, and then multiply here is -20x. Take the opposite, so that becomes positive, positive, cancels, 26x, bring down the 8. X divides into 26x 26 times, multiply, 26x plus 52, subtract, subtract, cancel, use my calculator, remainder of -44 all over the divisor x plus 2. So again, x plus 2 is not a factor of this third degree polynomial because my remainder is not 0. So here's my quotient, and here's my remainder. Wasn't so bad, but we can kind of clean this up a little bit by using this shortcut method. So right below here, I'm going to kind of take you through synthetic division okay, to get the same answer. All right, so what we do if we're going to use synthetic division on this problem is that I usually kind of set up this little symbol here. I don't know what you'd call it, but okay, I want to go ahead and put this little symbol here. And then across this symbol, I'm going to put the coefficients of the dividend. So I'm going to put the 5, the 0, the 6, and the 8. All right, so remember that these are the coefficients of a third-degree polynomial. So over here, when n is 3, okay, I'm just going to remind myself, these are coefficients of a cubic. I'm going to skip a line, and then I'm going to draw this other line down here. Okay, and what we do then is over here to the left of all these coefficients, I want to put the 0 of the divisor. Here's the divisor. The 0 is -2. It's the opposite sign. So I'm going to put -2 here. First thing we do, here's the process. We're going to bring down this 5. And we're going to put it below this line I drew, and I'm going to put a 5 here. Next thing I'm going to do is I'm going to multiply. That's what we did in long division. 5 times -2 is -10, and I'm going to put it right here, and I'm going to line it up underneath this 0. So now I'm going to add down, and I'm going to get -10. I'm going to do the same process again. -10 times -2 is +20. I line it up underneath the next digit. So now I add down and I get 26. 26 times -2 is -52. I'll add these two on my calculator and I get -44. All right, it might not seem like a shortcut, but it is. When we do this division, because that's what we're doing, we're taking a cubic like we did up here, and when we divide a first degree into a cubic, our quotient will always have 1 degree less than the degree of the dividend. So if this is 3, this is 2. If this is 5, this would be 4 if we use synthetic division. So I want to come down here, and in front of these numbers, I want to put the degree of that quotient is quadratic. Then what I do is I go back and I go, oh, okay, this last number is the remainder. Look at it up here. It matches -44. So this last number is the remainder. I use all these numbers before the remainder, and I put them back into a quadratic equation. So my quotient, Q of x, is 5, not x cubed, but x squared. And then in descending order, decreasing order, I fill these coefficients in for the other terms. Minus, then 10, then x. And then this is just your constant, plus 26. So my remainder was -44. And you could put it over x plus 2 or just do -44. So see how using synthetic division might kind of takes the variables out and you just work with numbers and a calculator, and it makes it okay. But then you've got to fit it back into your answer as far as Q of x and R of x. Remember, there's certain conditions with synthetic division, though. You can only use this shortcut when you have a linear divisor. All right, we need to practice some more synthetic division, but we'll do that in the next video.